this video, we're going to continue discussing confidence intervals, but what we're going to discuss here is when we do not know what sigma is, what the population standard deviation is. And it's more common than not that we do not know what the population standard deviation is. The reason for that is most of the time we don't have the population, therefore we don't know what the population mean or the population standard deviation is. So most of the time we're not going to know what sigma is. And if we don't know what sigma is, we cannot use the z alpha divided by 2. The reason for that is because when we're calculating x bar minus the mean divided by s over the square root of n, this does not have a normal distribution. And that's because s is more random, whereas sigma is a constant, and it increases our spread. And so we can't use the z or our normal distribution in this case. So what we're going to use is what's called the student's t-distribution instead of the z-distribution. So anytime that we do not know what the population standard deviation is, if we're not given that, if we have to calculate what the standard deviation is, if we found what the standard deviation is from the sample, things of that nature, we're going to use the student's t-distribution. And what it does is it takes into account the fact that it's not normal, the spread has increased, things of that nature. And so we also have to think about what degrees of freedom it comes with. Degrees of freedom are the number of independently variable factors. Remember whenever we were calculating the standard deviation for a sample, we divided by n minus 1 instead of just n like we did for the population. And that was because we wanted it to be more accurate. We didn't know exactly what we were looking at, and so we had to take into account that information. We do the exact same thing here. We don't know exactly what the population standard deviation is, so we have to take that into account again here. And we do that by using degrees of freedom and calculating that with n minus 1. And so when we're looking at the t-distribution, it is still symmetric and unimodal, meaning that the only has one mode, usually in the center. It is more spread out than the normal distribution, meaning it's usually flatter. If we increase the number of degrees of freedom, it comes closer to the normal curve. Meaning the larger our sample is, the more normal it's going to become and everything. So let's look at an example of this. And first we just want to find the critical value for t alpha divided by 2 needed to construct a confidence interval of level 98% and sample size 12. Well, our n for this one is 12, and our confidence level is 98%. So our degrees of freedom are going to be n minus 1, which is going to be 12 minus 1. So that gives me 11 degrees of freedom. And we're using the student's t-distribution, so I'm going to go to the t-distribution table. and I'm going to look under the degrees of freedom. So I'm going to go to the degrees of freedom, which are 11, right here. And then recall that at the bottom, we had the confidence levels, right here. And we're looking for the 98% confidence level. So I'm going to start drawing a box around it and scroll back up. And so the T that we're going to use is a 2.718. So it's very nice, since we have these confidence levels here, that we're just going to look for these confidence levels for the T distribution and find where they intersect with our degrees of freedom. And so the T that we're going to use is a 2.718. Now, a couple of things, especially with degrees of freedom. Notice that on our degrees of freedom chart over here for our T chart, not all degrees of freedom are over here. We skip around. And so what you do is, if the degree of freedom that you need is not on the chart, you're going to go to the one below where you need. So if I'm needing a degree of freedom of, say, 43, well, 43 is not on here. So what I'm going to do is I'm going to go to the one below it. So that's 40. Even if I needed a 49, I'm still going to go to the one below it of 40. In other words, go to the one that is below the degree of freedom that you need. And I'm going to go to that degree of freedom and look at that row. So now then, when we have this, we're still going to construct our confidence interval in the same type of manner that we did whenever we were using the Z, except we're going to just replace it with a T. We have to make sure that we calculate or compute the sample mean and the sample standard deviation, S, because we probably don't know it. It may be given to us sometimes. We have to find the degrees of freedom and then find our critical value, alpha, or T alpha divided by 2. We're going to compute our standard error, which our standard error is still the same thing, the standard deviation divided by the square root of n. It's just S divided by the square root of n this time. And our margin of error, we're still going to calculate the same way, except instead of a Z, it's a T this time, times our standard error, which is S divided by the square root of n. And then for our actual confidence interval, it's still going to be X bar minus, and then our margin of error, T alpha divided by 2 times S divided by the square root of n. We're still looking at the population mean, and then X bar plus T times S divided by the square root of n. And that's at T alpha divided by 2. And remember that we always want to interpret our results at the end. So let's look at an example of this. I want to suppose that you sample 59 high school baseball pitchers in one county and find that they have a mean fastball pitching speed of 80.00 miles per hour with a standard deviation of 4.98 miles per hour. Find a 95% confidence interval for the mean fastball pitching speed of all high school baseball pitchers in the county. Interpret the interval. So our sample size is 59, so that means my degrees of freedom is going to be 58, 1 minus my sample size. My sample mean is 80.00. And my sample standard deviation, I know that this is a sample standard deviation because it's all talking about the sample, is going to be 4.98. And I want a 95% confidence interval. So I have degrees of freedom of 58 and a 95% confidence interval. So I'm going to go to the t-table. Okay, I'm looking at a 95% confidence interval, which is in this column. I have 58 degrees of freedom. Well, 58 is not on here. I've got 50 or 60. I go to the one below what I need. So I'm going to go to the 50. Okay, and I'm going to use a 2.009. Remember to always go to the one below what you need. So you're going to go to the 2.009. So we're going to use a t alpha divided by 2 is equal to a 2.009. And we're going to calculate the interval. We're going to use 80.00 minus 2.009 times your standard deviation, 4.98, divided by the square root of 59, our sample size, is less than our mean, which is less than 80.00 plus 2.009 times 4.98 divided by the square root of 59. We use the exact same rounding rule. We're going to round to 2 decimal places because our mean is in 2 decimal places. So I'm going to calculate my margin of error, which is 2.009 times 4.98 divided by the square root of 59, and I'll get 1.30. So I'll have 80.00 minus 1.30, and I'll have 80.00 plus 1.30. And I will add and subtract that, and I'll get a 78.70 and an 81.30. And we want to interpret that, so we can say with 95% confidence that the mean fastball pitching speed of all high school baseball pitchers in the county, because remember, this is all the information that they gave us, is we're looking at this county, is between 78.70 and 81.30 miles per hour. Notice I'm very specific about what I'm talking about. Talking about fastball pitching speed of all high school baseball pitchers in the county. I'm not just talking about all fast pitching speeds. I'm talking about strictly high school baseball pitchers in this county, because that's what this particular survey is talking about. When you're interpreting results of confidence intervals, you have to make sure that you're paying attention to what is it talking about. So try some examples of using the t-table, trying to find the correct degrees of freedom, practicing using the confidence intervals, and if you have questions, let me know.